Welcome back to the Agent and MCP series. In episode 4, we are shifting our focus to the client. This is the code that actually lives inside your application, whether that's an IDE, a chat interface, or an automated agent. If you look under the hood of the Python SDK, you'll find that everything starts here, the base session. It's the foundational system that handles sending requests and processing results. Whether you are building a server or a client, you are inheriting from this base. But today, we care about the client session. While the base handles the plumbing, the client session is where the magic happens. It's responsible for three major capabilities that turn a static connection into a dynamic agent workflow: sampling, routes, and elicitations. Let's break these down, one by one. But first, basic hygiene. How do we know what our connected servers are thinking? The protocol provides a standard way to handle logs. Instead of just printing to a console where they might get lost, MCP servers emit logging notifications. Think of it like a stream of particles. The server sends everything: debug info, warnings, critical errors. But your client doesn't have to listen to all of it. By using set_logging_level, you create a filter. You might tell the server, only send me critical errors. In the Python SDK, this is asynchronous. You implement a logging_callback function. While your main agent loop is busy solving problems, this callback sits in the background, listening to the stream, filtering the noise, and capturing exactly what you need to debug your system. Now, let's talk about the most powerful and dangerous capability: sampling. Usually, a client asks a server for tools. But in sampling, the server turns around and asks the client for help. It says, "I need to use your large language model to process this data." Here is the workflow. The server sends a sampling create message request. It travels to the client. But, and this is critical, it should not go straight to the LLM. This is where you must implement a human-in-the-loop workflow. Think of it as a security gate. The request stops here. The user sees the prompt the server wants to run. Only if the user approves does the gate open. The request then travels to the LLM, which generates a response. But we aren't done. The response travels back to the user for a second review. Did the model reveal secrets? Did it hallucinate? The user approves it again, and only then does the result travel back to the server. This double-check architecture is the only way to safely let third-party servers use your paid LLM credits. Next up, routes. Agents need context, and context usually lives in files. Routes allow the client to define a sandbox, a specific set of directories that the server is allowed to look at. Visually, imagine your file system as a massive dark grid. Routes are the spotlights. The server can only see what is lit up. However, a warning: in the protocol, routes are a suggestion of boundaries. A malicious server could technically try to read outside the lines. Your host application acts as the enforcer, blocking those requests. The cool thing about routes is that they are dynamic. If a user drags a new folder into your app, the client sends a list changed notification. This signals the server to rescan its boundaries, instantly updating the agent's context without restarting the connection. Sometimes, an agent gets stuck. It needs a password, an API key, or a decision that it can't make on its own. This is where elicitations come in. Elicitations are essentially server-initiated forms. The server sends a schema, a blueprint of the data it needs. I need a string for the region and a number for the count. On the client side, this triggers a UI element like a pop-up or a chat bubble. But notice the control flow here. The user has three choices: accept, decline, or cancel. This decoupling is vital. Your client code doesn't need to know what the server is asking for. It just takes the schema, renders the form, and passes the user's structured data back to the server. It makes your client interface incredibly flexible. One of the best practices in MCP development is decoupling your client from any single model provider. Your client might be connected to Claude today, but what about GPT-4 tomorrow, or a local Llama model? They all speak slightly different languages when it comes to tool use. We solve this with the internal tool pattern. Imagine a prism. The MCP tool comes in as a standard protocol object. Your client class acts as this prism, translating that object into the specific JSON format your LLM expects, whether that's OpenAI's function calling format or Anthropic's tool use format. By abstracting this translation layer, your agent becomes model agnostic. In a real-world production app, you rarely connect to just one server. You might have a calculator server, a GitHub server, and a Google Drive server. Managing these individual connections is a headache. Enter the ClientSessionGroup. Think of the session group as a switchboard. You plug all your servers into it. To your agent, it looks like one giant super server. When you ask for tools, the session group aggregates them from all connected sources. But watch out for name collisions. If your calculator has an add function, and your spreadsheet server also has an add function, the session group will throw an error. You can use the component name hook to rename them on the fly, turning them into calcadd and sheetadd to keep everything organized. Finally, let's talk about resiliency. The internet is messy. Connections break. If you are using SDIO, that is pipes, a broken connection usually means the process died. But with SSE, server sent events, we can recover. MCP servers attach an ID to every event they send. Your client should save the ID of the last message it successfully processed. If the line goes dead, your client reconnects and sends a last event ID header. This tells the server, I heard you up until message 105. Please replay everything after that. It zips the connection back together, ensuring no data is lost. Combine this with pagination for handling large datasets, and OAuth for security, and you have a robust, production-ready MCP client. That wraps up Chapter 4. You can find the full code for the session group and the sampling implementation in the GitHub repository linked below. Thanks for watching. Let's wrap up with a few essential patterns you'll use daily. First, progress notifications. Don't leave your users staring at a frozen screen. As your agent processes a long task, use send_progress_notification to update them in real time. The client tracks this with a token, so the user always knows where they are in the pipeline. Second, pagination. When you're working with large resource lists, thousands of files or database records, the server doesn't dump everything at once. Instead, it returns a page and a next cursor. Your client keeps calling list_resources until the cursor is null. Finally, security. For local SDIO connections, environment variables can hold secrets. But for HTTP connections over the network, you must implement OAuth 2.1. This involves a proper token exchange. The server issues a token, your client stores it, and passes it in headers for every subsequent request. This keeps your API keys and user data safe. Master these patterns, and you'll have a truly production-ready MCP client.